In this video, I'm going to talk about functions, just the very simple functions. When we write programs, we need to design them first. And basically, when we're doing procedural programming, we do it like we're writing a paper. We come up with an outline, which forces us to think at a higher level about our program, not worrying about details. So let me just get into the editor here. I created a file called functions.c, and I will include standardIO.h so that we can use the printf function to print some stuff to the screen. And I will create the main function, which we now know every hosted C program starts processing at the main function. Now, when you program, if you get too wrapped up in the details, your programs become very messy. And so we want to think like an English teacher or somebody who's writing an outline before they just dive right into writing their paper. And so let's say that we had some function that we wanted to accomplish, like processing the Wells Fargo transaction file or the checking data file. We could do it sort of like this. We could say load transactions, process transactions, output report. We could do something like that. So we're thinking about it at a very high level. Of course, those aren't C commands, and so we need to actually tell the compiler about these. But let's go ahead and try and compile this real quick. So I'll say clang functions.c, and it tries, but I get an error for load transaction, process transaction, and output report, because it doesn't know, the compiler doesn't know about these. And so we have to tell the compiler about these. So I'll go ahead and declare them up here. And I'll say, all right, so load transaction is a function returning a void, takes no parameters. Process transaction is a function returning a void, and it takes no parameters. And finally, output report is a function returning a void that takes no parameters. Now here, in lines 3, 4, and 5, we've told the compiler through a mechanism called prototyping that you're going to encounter these names, and trust me, I've defined them somewhere else, the body of the code. So let's give this a try and see if we can compile these. So now we compile it, but we get different errors. We now get undefined symbol errors as opposed to the implicit declaration of a function error. Okay, and LD is further along in the C and C++ toolchain. We've already gone through the preprocessor, we've already gone through the compiler, and now the linker's invoked. That's what LD is. And it's complaining that it didn't find some stuff. Well, that implies that the compiler finished doing what it was supposed to do, because our code is good. We've got a main function. We're telling the compiler, hey, don't worry about load transaction, process transaction, and output report, because I know what I'm doing and I've defined those functions elsewhere. But of course, by the time we got to the linker said, hey, I've got these 3 symbols and I can't find the code that goes with them. I can't find the body of these functions. Okay, so we can now go in and create stubs. And stubs are what we do before we figure out all the nitty-gritty details of what load transaction's actually going to do. And so we just do something like this and say printf load transaction. Get my other double quote in there. And so we'll just print to the screen the fact that we've called this function, and this gives us something on the screen to prove to us that it's actually been called. Okay, and so that's not the end. You know, we don't do anything in load function except print a message to the screen, but it helps us get our program structure together. And that's why this is called a stub function. It's just a stubby little function that it hasn't been implemented yet. So I'll do the same with process transaction. Put in my curly braces, and I'll go up here and I'll yank, and then I'll stuff this in here, and I'll change this to process transaction. Yank that, and then I'll do it again. I'll say void output report, a couple of curly braces, and then I'll say output report. So now I've got three stub functions, meaning that they just do nothing, but they give us a visible way to see that our program is calling these functions. And so now I'll go out and I'll compile these, and now I get no errors, and I have this a.out. That's my executable, and you can see load transaction was called, process transaction was called, output report was called. And the reason we're doing this is because we don't want a big messy main function. We want to think at a high level, at that outline level, and then later on we'll figure out how to write the detailed functions that get things done. And if a function gets too detailed, then you need to break it up into a couple more functions. And so really your C programs should be a lot of little functions that do one thing, do it well, and is easy to test. So now I can call functions from other functions. So for instance, if I'm in output report and I want to call the process transaction function, I can say process transaction, recompile, rerun, and notice now that load transaction is called and returns, process transaction is called and returns, and then output report is called and it calls process transaction. So now I've got a nested call to functions. So here I should probably do something to set it apart and say when I call it from here, I should probably do something like printf and just stick a tab out there just to push it over a little bit. And no new line. There we go. Okay, and that way you'll see that it actually did get called from inside that other function. Okay, so think about writing or designing programs at a high level, at the headline level or the outline level, and build your code to mirror that architecture. And don't worry about the details. We'll start filling them in as we go.